All right, guys, continuing with lesson 4.3, we're going to look at task 4, and this time we're going to look at the characteristic to determine extreme values. All right, so extreme values can be your minimum and maximum values. So the minimum of a function is the y value of the lowest point on the graph. The maximum of a function is the y value of the highest point on the graph. So consider the function f and g. For each function, find the domain, range, max, and min. Okay, so you can see the minimum value, it says, is the y value. So the minimum comes from the y-axis, because that's your vertical axis. And in this case, the minimum value of this line is negative 7.5. The maximum value would be 7.5. All right, for g, you can see that it continues infinitely in this direction, and it continues infinitely to the right. So both to the left and the right, it continues. So that means the domain for this one is all real numbers. All right, so this says the domain of f. Again, the first function is f, so the domain is your x's. It goes from negative 5 to positive 5. So they wrote this from negative 5 to positive 5 is your domain. All right, choose the best options to complete the sentence. The endpoints of f are, let's look one more time, negative 5 and negative 7.5. And the other side is 5 and 7.5. Just double check. Yep. All right, so it says the range. The range, remember, comes from your y values. So the range of f goes from the lowest point to the highest point, so negative 7.5 to 7.5. And it says the maximum and the minimum, we already looked at that when we looked at the graph a minute ago. The maximum is the highest point, or it comes from the y, which is 7.5. The minimum also comes from the y-axis, but it's negative 7.5. All right, now it says the domain of g is all real numbers, so we also looked at that. The fact that these have arrows means it continues in both directions, and that makes it all real numbers. All right, it says, does the graph of g have endpoints? No, if it has arrows, it means it continues infinitely, so it does not have endpoints. The range of g is all real numbers. G has no max and no minimum. Why doesn't g have a max or a minimum? For the same reason. If the line continues infinitely in both directions, there is no maximum or minimum. All right, if you want to pause the video, we're going to move on to task 5. All right, looking at task 5, determinant extreme values. Tasha is filling a car with gasoline. The volume of gas in the tank increases steadily until the pump stops when the tank is full, as shown in the graph. Identify the minimum and maximum of the function given by the graph, and tell what the minimum and maximum represent. All right, so you can see here, it starts at 0.4, and the bottom is time in seconds, so that would be your x. In this case, they're calling it t. And up along the y-axis, they're calling it v. So it's just the function is v of t, but it's still your x and your y-axis. And this would be gallons of gas, okay? Volume of gallons of gas. So it starts at 0.4. and it goes up to 72.16. All right, so it says the minimum is 4, which is the number of gallons of gas in the tank before Tasha begins to fill it. The maximum is 16, which is the number of gallons of gas the tank can hold. Choose the phrase to complete the sentence. The t-coordinate of the graph's right endpoint represents what? So the t-coordinate is on the x-axis, so it's the first number in your ordered pair. So it represents 72 seconds, okay? 72 seconds. All right, it says, what would happen in this context if the domain is extended beyond 72 seconds? Well, it shows here at 72 seconds, the gas is full at 16 gallons of gas. So if you kept pumping gas after it's full, the gas would overflow onto the ground. So you definitely don't want to do that. All right, that one was quick. We're going to move on to task 6. All right, hopefully you paused the video and found task 6. This time we're just going to identify characteristics of a linear function. So it says match the given linear function to the corresponding characteristics so that each function is paired with only one characteristic. All right, so if you remember linear functions, that's what we've been talking about for a couple days now. Linear functions have equations that represent a line, okay? And all these characteristics we're looking at, now we're going to look at how to kind of match them up. All right, so this one says it has a y-intercept of 5, and this one has a y-intercept of 5. So if we go over here to the graphs, we can look. This is slope-intercept form, y equals mx plus b. So that one has a y-intercept of 5, and this one does as well. Now, what I can see about this function is it has a positive slope. So if I have a graph here and it has a positive slope with a y-intercept of 5, let's say that's 5 up here, and I can't draw a line to save my life, but I'm trying. Let's see. Okay, so let's say that's 5 right there. Okay, so that's supposed to be a straight line. Pretend with me that that's a straight line. But this has a positive slope, and now we want to determine the end behavior. So this says as x goes positive, we know that this is x positive, and over here is x to the negatives. All right? So as x goes positive, your y value also goes positive. So that means C has to be paired with this one, which means this one has to go with that one. But we also can look at the slope, and we can say that this one has a negative slope. It goes down, so that means as x goes to the right, y goes down. So that makes sense. All right, now let's look at these next two. These both have a 0 of 2, but one's decreasing and one is increasing. So again, let's look and see what we can tell. So 2 means when we plug this in for x, y is 0. So if I take 2 and I substitute it in up here, 2 times 2 is 4, or sorry, negative 4 because that's a negative 2. Negative 4 plus 4 is 0. All right, so that one has a 0 and it's decreasing. How do we know if this function is decreasing? It's negative, so that means it is decreasing. So we know that this one has a 0 of 2 and it's decreasing. All right, so we need a 0 of 2 again. So 2 minus 2 minus 2 is 0. So that fits that, and it's increasing. Well, this is positive. The slope is positive, so this one is increasing. All right, this one says it has a negative 4 is a 0. All right, negative 3 times negative 4 is 12. 12 minus 12 is 0. 0 is what we're looking for. That is the 0. So, and it's decreasing. Negative 3 means it's got a negative slope, which means it is decreasing. All right, so you can either graph these and look at these characteristics, or you can just, if you get to know what the equations are and what the positive and negatives and what the y-intercepts and what the slope and all those things tell you, then these are not too difficult to match up. All right, we have one more. If you want to pause the video, we're moving on to task 7. All right, guys, still looking at identifying characteristics of linear functions in 4.3. We're going to look at a tree farm. All right, it says a hybrid popular tree was planted at a tree farm. The tree grew for 10 weeks at the farm and then was sold and transplanted to a customer's lawn. The graph shows the tree's height, h of t, as a function of time while it was at the farm. Tell whether the function is increasing or decreasing. Then identify the function's domain, range, minimum, and maximum. Okay, so before we start, let's just evaluate the graph. So across the bottom, that's time in weeks. So we can see that it goes from 0 to 10 weeks. We can also see that the height in inches is along the y-axis, so it's going to go from 0 up to 60, but it starts at 40. So this represents 40 inches at week 0. And then the tree grew for 10 weeks, and it became 55 inches tall. All right, so let's answer these questions. So it says the function is increasing. We can see that from left to right, the line's going up, so it is increasing. And the the domain goes from 0 to 10, and that's your time in weeks. So we did say that it goes from 0 to 10. So t is between 0 and 10 weeks. And the range, h of t, or your y values, go from 40 to 55. And we did see that the height goes from 40 inches and it grew to 55 inches over that 10-week period. All right, so it says, what do the minimum and maximum values represent in this situation? All right, so in this situation, the minimum value represents the height of the tree at week 0, so when it was planted or at the very beginning. And then 55, the maximum height, represents how tall the tree is after 10 weeks before the farm sold it to a customer. All right, it says which statements about zeros as a function is true? So the function has a 0 when t is 0. That's not true because it doesn't start at 0. It starts at 40 inches, so it doesn't have a 0 there. The function has a 0 that's not shown. Well, if this line continued, it would be negative, and we can't have negative weeks, so that's not a good solution either for this situation. So the function does not have a 0 because the height is always positive. That has to be the correct answer. All right, if you have questions, please let me know.